Welcome to this course on modeling and data structures. In this first unit, we will present the concepts of modeling and structured data regarding the use of UML and XML. So, what is UML? UML is a language that allows us to visualize and specify and document the data easily. With UML, we can cover most of or even all the application's data. UML is a standard for both software modeling and structuring. With this, we can have 9 different standard diagrams. Static view diagrams, which include diagrams like use cases, classes, objects, components and deployment, or dynamic view diagrams, which include diagrams such as sequence, collaboration, state charts, and activities. Our main focus today are the class diagrams. A class diagram models the application's vocabulary from the point of view of the user or problem, or the implementer solution. In a class diagram, we can have classes, of course, attributes, operations, associations, objects, multiplicity, etc. But what is a class? A class is a representation of the different kinds of things. In a certain system, like a person, a car, a property, roles such as a student, teacher or a pilot, events or even data like a date, a number, etc. In UML, a class is represented by a rectangle, but these rectangles can be filled by more information about each class. We can have attributes that characterize the class, and each attribute should have a unique name inside the respective class and also a type. We can have operations representing the behaviors associated to a class, and we can also have associations representing the relationships between the two different classes. And each association can have a certain multiplicity on each end of it, such as 1, that represents exactly 1, 0 or 1, 0 or more, represented by the asterisk, 1 or more, 1, 3 or 1, 3 or 5. There are also aggregations, associations, or stronger associations where one class is part of another, and composition associations represented by a filled diamond, which represent even a stronger relationship. But what is in concrete an association? When a new association appears, it can introduce a new class that describes the connection. Furthermore, we can also have generalizations to represent inheritance relationships between classes. Lastly, about UML, we can have objects, which are instances of a class. While a class represents an abstract element, an object represents something more concrete. While attributes are set at the class level, attribute values are set at the object level, and one object of the same class have the same operations. Now, moving on, different data can be structured through markup language, which consists in a group of words and symbols that describe the identity or function of a document component. XML lets you create and draw markup language with several possibilities, being why it's an extensible language. With this, we can create and draw markup language with unlimited possibilities. A well-formatted XML should have one or more elements, a root element, and elements interconnected. But what is an element? An element is a representation of a piece of data that we want to structure. An XML element is represented using tags, an easy expression using this notation. All XML elements must have a start and end tag exactly equal to close the respective element. Also, empty elements don't need an end tag. With these elements, we can only use the bar at the end of them. An XML element can have attributes. While an element typically represents concrete data, attributes tend to represent metadata, data about data. If we want to restrict XML, since it's a free language, we can use XML Schema Definition, or XISD, for instance. Thanks for your attention.